All right, good morning, everybody. This is Jorge Fernandez, and welcome to this session today of KETIV AVA on Inventor bolted connections. We will have a little bonus session at the end as well on doing bolt design validation, by the way. So for those of you that can, I'd encourage you to stick around, of course, at the end. Well, let's go ahead and jump in. So the goal for today is that to give you a little more information about bolted connection. For those of you who haven't used it, how to use bolted connections. Hopefully for some of you that are using it, how you can use it maybe a little bit better, what some of the different tools are inside of there. So we'll explore that. So before we get started, where is it? What does it do? So bolted connection, you'll find when you go into an assembly and when you want to do a bolt washer nut combo, for example. It could be just a bolt and a washer, usually not the case, but sometimes, right? And then you have a bolt and just nut. So we'll show you how you can do just that. And where it's found is when you're inside of an assembly under the Design tab. That Design tab actually stands for the Design Accelerators, which comes with Inventor, both the standard Inventor and Professional. They give you options to do like frame generator to create a frame out of a solid or different 2D and 3D sketches. But today we're going to focus on bolted connection. And then the parts that are created inside of here come from the Content Center. So the first thing you'll probably want to do, if you haven't already, is maybe go to our playlist on our YouTube channel. If you go and just search for KETIV, you'll find that right in there. And there's a couple sessions on Content Center parts and making sure that you have your library set up. So let's go ahead and jump right into it. We'll go over to Inventor and show you how to use bolted connections. I thought I'd bring up this example here. I created this frame using frame generator inside of Inventor and showing you how you can use bolted generator to get these types of bolts inside of here. You can use it in a few different ways, so we'll go over some of those different methods right inside of this assembly. The first thing you want to do, as I mentioned, is you have this Design tab. In this Design tab, you'll find bolted connection up at the top. Again, don't forget the Content Center. You do have to have that active, and to do that, you would go under Get Started and Projects to make sure it's actually part of it under Configure Content Center Libraries. So that's what those videos in our playlist will show you. So back over here in the Design tab, we'll go to bolted connection, and what it'll do is it'll bring up a wizard, really. I have to admit, it's not very appeasing necessarily, but it will get the job done. It is a wizard that walks you through getting a bolt on this frame. So I'm actually going to flip it around here to the opposite side that doesn't have any bolts on it and show you how we can place it on here. So the first method I want to show you is that there's these different placements, and the one we're going to look at first is linear. So it's much like using the hole command inside of Inventor part mode, actually. So hopefully if you use that already, you should be somewhat familiar with it. And what it's going to have you do here is first you pick what type of hole you're going to do. Is it going to go through all parts, or is it going to be a blind hole? And then it's prompting me to pick a start plane for it. So once I come over here, I just go ahead and click on it, and then it's going to jump to the next thing it wants, which is a linear edge. So I'm going to pick from the top, for example. And then I can type in the dimension I want. I'm going to go 2.5 inches down. And then I'm going to go from the edge, I'm going to go 1.5. And accept that. The next thing it's asking for is the termination, meaning where is this bolt going to end? Which then allows me to come over here and select the other side of this. I'm going to go ahead and rotate this around, actually. I like to use the little orbit command here so I can recenter this, by the way, for those of you who use the orbit command. You might have already realized that. That's my termination. Now the next part is what type of thread am I going to want? So I have the different profiles right here. I can use ANSI, metric, ISO, GB, for example. But I'm going to go with the ANSI here, and then I can pick the diameter that I want for this. So this is automatically, or I should say, is going to help me in clicking and picking the right fasteners that I want to add to this. So I'll go ahead with the 0.5 diameter, and I am seeing a preview here on the assembly as well. The next thing is, over on the right-hand side, this is where we start to tell exactly what we want it to do. So these right here, you notice how these are in yellow, the color yellow? That means that it's going to create that hole for us because the hole's not there already. So once we click on that, we can also choose what's going to happen with this hole. Notice first of all that this diameter is a little bit larger than the diameter we show down here, because it's of course giving you clearance for that bolt. So if we go in here, what these pull downs mean, or these other options, this down arrow allows me to pick the standard that I want first of all, and then what type of hole I'm creating here. Is it a drilled hole? Do I have to do a countersink? And if I choose a countersink, by the way, notice that the preview does update, and I get to see that right on here. In this case, I think a countersink won't necessarily work actually. We'll go ahead and change that to a standard drilled hole. So once we've identified that, the next thing is we want to be able to list here what type of hole this is going to be, as far as, is it closed, is it normal, do I want a loose fit, is it custom where I type in the diameter, or is it threaded? So if I wanted to make it a threaded hole, this is where I would pick that, and then I can give it the information I need for the actual thread profile inside of here. So again, this can come in really handy. I think for some people, sometimes we've used bolted connection. I've seen them kind of glance over this part, but do realize that it can create all the holes for you. Quick thing I want to mention though, be careful with this. It's a great tool. Don't abuse of it. What I mean by that is, if you do this to all the holes in this frame, bear in mind that it's going to link things to each other, and it could cause updates to take just a little bit longer. So it's just one of those things that I like to say, it's a great tool, but use it, to maybe to create it at first and break the link, or make your holes first and then create the bolted connection that you need to have here. It just depends on how much you're going to use the bolted connection. So I'm going to go ahead and change this to normal. Accept that. Of course, I can come down here and click on the second one, which would be the second hole, or really the hole in this channel in the back. Now the next thing I want to do is to tell it how I want to add the nuts and bolts and so forth. So if I come over here and click on select a fastener, it's actually a command that picks up all the content from your content center. So it is picking ones that have that diameter that you chose. This can be a pretty big list because, of course, this is reading off your content center. If you do have your own custom part, it will read that too, by the way. So it doesn't have to just be the standard out-of-the-box stuff. So I'm going to go over here to my ANSI standard to bring this list down a bit. I have all my bolts in here. And we can scroll down to the bottom here to get to the ones I want, which I want to use a hex cap screw inch. You'll notice a preview now comes up over here. I can see what that bolt looks like. Let's go to a side view so we can see it just a little bit better. Here we go. It's showing me the bolt. You notice that there's a length to it right here, and it automatically calculates the length depending on where the termination was. So that's why that was important, because it'll adjust the length for us. We can override this. We can make it bigger. We can actually make it smaller as well, as long as there is a bolt that size, of course, and it's standard. So we don't have to go by the default necessarily. So if we come over here, you'll notice that it says click to add a fastener again. What this means is, well, not to add another bolt necessarily, but what's the next thing we might need to add? Usually it'd be a washer right here. So we can come over here and again filter this down to the different standards. I'll go to ANSI, for example. And we come down here and I'll go with a plain washer inch. So what you'll notice is now the preview updated, and it showed me where that washer is going to be placed roughly, so I can get an idea of what this is going to look like. The length actually changed for me as well to adjust for that and jump to the next length available. Over here, I can still always go back, by the way. If this was the wrong washer, I can still come back here and pick a different one. So you're not locked down. You can always go back and forth and make changes as necessary. So typically, what would be next is, after all of this, we want to add maybe another washer and or a nut. So we come down to the bottom here. Notice there's this double line showing me it's after the hole, and I can click to add a fastener, and sure enough, it's prompting me for washers. But you can go to nuts or sheet metal nuts for that matter. So if I choose one of these and filter it out, I can do that through here. I can always hop back and forth if I need to, and change it again as well. So I'll add another washer at the end, and finally I'll add a nut as well. There you go. Hex nut inch is what I'll use. So you notice as I was picking those different things, it automatically grew that bolt. So I don't have to, manually do that. Again, if I wanted this to go halfway into the nut, I could do that by just clicking this arrow like so. I can again click this length here, and you notice it snaps to the different lengths. Now that I've created this set so far, well, what if this is a set I want to use over and over again? Not a problem. Down here at the bottom we have this templates library. The templates library is going to allow me to come in here and add this to this library so I can reuse it over and over again. So I'll just add a quick name for that. What's great about this too is notice I didn't put the actual diameter of this, and that's okay. The reason for doing this template is that it is just a template. It doesn't necessarily have to be the same diameter every time. It just picks this screw type, this washer type, this inch type, this nut type as well. So I can go ahead and do that, and I can reuse it over and over again. Before I finish up here, what are some of the other tools we have inside of here? So we also have what we call the calculation. So first of all, before we go to calculation, you can enable it right here. Why you have to enable it, not sure, but that's where you enable it first. And then you can go to the calculation tab. So what this is not a full-on FEA analysis. It's just a quick calculation. Instead of you having to bring out your engineer's handbook and having to do these manual calculations, it'll do the math for you. So what this allows me to do is to say, well, what is the axial force that's being put on here? And do I know what the tangential force is? Do I know the tightness factor? I can use the material that's already being used by this content center piece, or I can override it as well and see what would happen if I use this other type of material instead. If you do activate this, then it gives you a little browse here to be able to see all the different materials that could be used for this. You'll actually notice, by the way, that these materials are a little more, they actually gives you more variety than you get in your usual library. So, nice little tool. I think it doesn't get used that often, but again, this could drastically help you in getting a little bit validation up front without going FEA just yet. And once we are ready to make these calculations, we can go ahead and hit the calculate button. Now, once you hit calculate, it'll give you the actual results over here. But what about if we were to, what if it wasn't going to work out? I'm going to make this just a little more drastic. We'll put 10,000 pounds on here. I wouldn't expect it to take that. But we'll see when we calculate it, it exceeds the stresses here. And it tells us that we need to reduce this basically by showing it to us in red. So that'll do the trick right there to do this calculation without you having to use your engineer's handbook. I'm going to change this back though. Just like to see it all in so it doesn't show up as red. There is a fatigue calculation tool inside of here as well, and this will allow us, well, before we do that, I'm sorry, we do have to enable that first once we've done this calculation. So don't forget to enable it, and then I can go to the fatigue calculation. So this, again, is just a calculator tool, basically. Instead of you having to run it manually, this is one way to do fatigue calculation. In the bonus session, we'll talk a little bit about the other tools we have to do things of that nature, and not necessarily have to go this route either. So we can actually see it visually, see those stresses on the actual part in the assembly, instead of just using these calculation methods. All right, back to the design. So in the design here, the way, again, I did this is by doing a linear placement and selecting all these, the set that I'm going to use. Once I hit OK, what's going to happen now is it's going to create a subassembly for you. So this subassembly here is it's going to give it its own name, bolted connection 3, which could be fine, and the next one's going to be bolted connection 4. Maybe not ideal for finding out which bolts which, especially if you have a lot of different ones in your design. So you can come in here and you can change the name of it by just going to this browse button and then just saying what you want to call it. I'm going to call it AVA-BC for now. Of course, usually you'd have some type of numbering scheme would be ideal for this, right? We'll have that right there. We can also change this display name if we wanted to over here on the left-hand side. Notice there is always this prompt for file name as well. So if you're okay with the default generated one, you can do that here. If you're using Vault, that might not be the best idea, and you might want to actually use unique file names, right? So keep that in mind. Once we hit OK, it's going to create that set for me. It's going to create that subassembly for me, and we see the parts with the cosmetic thread and all. And we'll just rotate a little bit. There it is. Now, let's look at the browser. What happened to this bolted connection? So we see that over here is that bolted connection 3. We see that all the parts are inside of there, and it's a subassembly. Well, the next thing you might ask yourself is, well, what happens to the bill of materials? Do I now have a subassembly that I have to manage separately? Well, if you go to bill of materials, you'll notice, and I'll just make this a little bit bigger. It does show in the model data, because that is basically like looking at the model browser, that it's a bolted connection. However, if we go ahead and enable structured, we'll see in here that it's not a subassembly anymore. It's just the parts. The reason for that, if I go back to the model data, is that this subassembly becomes what we call a phantom, which means that it's not going to show up as an actual subassembly in your bill of materials or your parts list, the subassembly itself. However, the parts are going to show up as standard parts inside of here. So that will help quite a bit for most of you. I think I've had people ask me that and are kind of afraid of having subassemblies in here of these bolted connections, but no worries. It does break it down into all the different parts so that you'll get the right part counts and everything for these bolts. I wanted to show a couple other methods really quick of inserting this bolted connection. So I'm going to go into this part, and really quick I'm going to create a sketch on here and just create some holes. Won't take too much time. For now, I'm going to cheat actually, and I'll just I won't dimension it for now. Not that I usually want you guys to do that, and I'm sure you wouldn't. Oh, forgot to add the hole. We'll add that hole. We'll make it. Let's make it 0.5 again. Through all. So with the hole existing, I'll go back to my top level assembly. And in the Design tab, I'll go to Bolted Connection again. So the other methods I have here is the ability to do concentric. So if I have a rounded surface, I can have it line up to that center. If I have a point, I can go with that. Or if I have an existing hole, I can do that as well. This is probably the most common one I've used and have had people use, because this way you're creating your own hole, yet you're still able to use that hole to make your thread. So I'll come over here, go to my start plane, go to my existing hole, and choose the termination on the opposite side again. Here we go. And then I can choose my diameter over here. It is picking 0.5 for me because of the 0.5 diameter. Typically, you'd have to look at that though, right? Is that hole really threaded? Is it a clearance? So you might have to, don't forget about that part. It's not going to choose or change this existing hole for you. However, it did pick up that the termination was on the back side of that channel, and it does want to create a hole there for you. So again, it'll still help you. It'll make sure that you do have holes assigned wherever you have that. So this could be a good way also to kind of catch yourself and make sure those types of things don't happen. Lastly, what I'll do here is I'll take this bolted connection AVA and I'll set it, which what you'll see it does, it automatically picks it up, fills in everything, and allows me to move forward. One other really nice thing here is we have this follow pattern option, which means it'll pick up wherever it has that same hole as well. You'll notice it picked up this hole even though I didn't use the pattern feature. So another great tool right there. You don't have to use a pattern feature for it to pick up the holes that are similar to it, so you can quickly be able to fill this out. Especially handy, of course, when you have multiple holes. We're talking 10, 15 holes or something like that that you want to fill in with the bolted connection. I can now click OK. I can change the name of this as we mentioned before, and now we have those bolts in place. So I hope you've seen so far, how much time savings this can be. I know, I'm taking, 20 minutes or something like that to explain this part of it, but really, this is a matter of seconds, where if you were to go your normal way and go to place component, place from Content Center, you'd place it in there, choose the hole you're going to put it on and so forth. The reason I'm bringing this up right now, though, is do realize that when you do go to one of these bolts and you do decide, I want to bring in something from the Content Center. We'll pick this one, for example. And we'll go to a hole here. For now, I know I'm going to be placing it on top, but just to kind of show you something really quick. This auto drop tool that comes up, what typically this does is it finds the right bolt size for you, but there is also a bolted connection button here. So even if you decide to go to Content Center, there is a reminder here to say, oh yeah, why don't you go to bolted connection and make your life just a little bit easier. So I think that's a great feature. Don't forget that you can always get to it from here as well. I just wanted to make sure I made that very clear for everybody. So something else where you might see it, come in more handy is maybe something like this. We have this hub here, for example, that we can work with, and again, we can use something like the bolted connection here, where we can just easily set it up to put it in one of these holes, and then use that follow pattern so that it automatically fills in all of them. Right now we did one with 2, but this one's one of 12 holes. Make my life a lot easier just to have that in. And then what makes that even better, since those are Content Center parts, when you have larger assemblies and you want to minimize the amount of resources you're using for your computer, then you can take advantage of this level of detail, for example, so you can suppress all Content Center parts. So you're not seeing any of the hardware. You can bring it up whenever you actually need it. So in summary, what we looked at right now is what is bolted connection. Again, it's a tool to make you more efficient in placing bolts, nuts, and washers. You access it through the Design tab when you're inside of an assembly. You can also get it when you drop in a part from Content Center. So it works a lot like the hole command, but it's in an assembly, and it'll let you choose from a hole that exists already. You can linearly place it, or you can place it concentric to something else, and it's using parts from the Content Center. Don't forget you can save it and use it as a template. That is something that's per user, by the way, so it's not like you can just set up that template for everybody at this point, at least. So I'd like to go into the Q&A session. Don't forget, for those of you that can hang out just a little bit more, we'll have we're having a bonus session right after this. It'll be only about 15-20 minutes to show you how you can actually do a design validation on that. So let me look at some of the questions that have come in here. All right. Oh, one quick clarification. I know I said you don't set up the templates for everybody. Of that set, that nut washer combo, but you can export that, by the way. So if you have colleagues that you want to share the templates that you've set up for those combos, you can definitely share that with everybody. So I have a question here. Is it possible to create a bolted connection without creating it as a subassembly, so it inserts the bolts and fasteners as individual components? You can't. It does do an automatic subassembly for you. Another reason for that, by the way, something I wanted to show really quickly, was when you have those bolted connections, then you can easily go back and edit them. See, if I right-click and edit using Design Accelerator, I can go right back to the same dialog and make changes to it again. And again, don't forget that subassembly is phantom anyways. It's just really a placeholder, if you will, to be able to go back and make these types of edits. Someone's mentioning here using this tool for large assemblies. Yeah, keep in mind that this tool is really nice to be able to populate these things really quickly, but use it with caution if you're trying to use it to create the holes. I wanted to definitely reiterate that and make sure that you understand for larger assemblies you'll have to use it with a little more kind of thinking ahead of for that. I'm getting also a question about using bolted connections along a curved surface. So if you want to use it on a curved surface, what you probably have to do is create a point, like a work point or a sketch point that you can use. If you remember, in bolted connection you can also use a point. So that's probably the way I would do that. I also have another question here saying, when you use your own library of parts, is there any extra setup or changes you have to make to use it? That's a great question. What you do need to do is, if you have a part that you want to use, let's see, I'm just going to go to one of these parts to show you an example really quick. you'll want to go to the Manage tab and make sure you publish that part. So under the publishing tools here, under Manage, Author, you'll have component authoring here. So this will make sure, walk you through a wizard where you're able to set it up and kind of use those same auto drop tools that were used for the bolts that we use as well. So you do have to author it and use this tool in order to get it to work inside of bolted connection. Oh, someone asked what happens to the actual hole that is created on the part itself. So if we go over to this part, let me show you exactly what that looks like. I will open up that part, and you'll see that it does create a whole feature for you, and it is associative to that original one. So you can still suppress these features if needed. If you were to delete the bolted connection, it would delete this feature for you, but it is associated to that bolted connection. So if you change it, it would automatically change this feature as well. One good point a colleague just brought up actually is also when you are wanting to use bolted connection and publish your own part, if it is already a content center part, that an existing one that you want to change, then you don't have to use the publish command. So again, if you have an existing content center part and you changed it, you want to just make it your own, you won't have to publish it in that sense. All right, here, I think that's all the questions, at least I can see. There was quite a few today. Thank you, everybody, for the questions. Let's go ahead and move on to the next session.